All right, so in 6B, there's some questions in question number 3 in the book, and then these become a little bit more difficult. So once again, we're solving rational equations, and so I'd like to do a few here so that you can see how they're done. So if we look at, say, question A for the time now, first rule, we have to get rid of the denominator here. So we should learn back in the algebraic fraction section is that we have to keep these things here together as a block. The x plus 2 has to stay together. So in order to get rid of 6 plus 2 in the denominator, we do the same thing as if they were numbers. So for example, if I wanted to get rid of this 3 here, I would put the 3 up here and it would cancel, and I would have to multiply this side by 3, okay? So I would have 3 times 3x plus 1 is equal to 2 all over x plus 2, all right? Now the next thing we need to do is try to get rid of this denominator, but since this is a group of terms with this plus or minus between them, we have to keep this together. So to get rid of this whole thing, we have to put that up here. So if I put x plus 2 here, these things cancel completely. But then, of course, I have to put this x plus 2 on this side. So what you end up having is something like this. And now we've gotten rid of the denominators. So the next thing we need to do is expand always. So I expand into these brackets. So 3, we have 9x plus 3, and we have 2x plus 2. Now we go back to one of our other rules, everything with algebraic terms on one side, so I would like to have him over there. So I go minus 2x, and they go away, but I have to put minus 2x on this side, and I have to put a plus sign in between them to make sure that I add them together, right? Because 9 is positive here. So that gets rid of my algebraic term. If you're comfortable, we can also get rid of this number on the left side. So if I subtract 3, that goes to 0, but then I have to subtract 3 on this side, okay? So if we do this, we have negative 2x and 9x, which gives us 7x equals 2 subtract 3 is negative 1. And finally, we divide out the coefficient in front of the x, as we always do at the last step, and we have negative 1 over 7. So there's our first one here, all right? So getting rid of the denominators again, just like the previous video. I'll do a more complicated one for you here. So if we take this and move this, let's grab one where both the denominators have algebraic term in them, okay? So if we do it like this, all right, first thing we should know is that we have to create a block underneath here. These have to stick together and these have to stick together. So if I put x plus 2 on the top here to get rid of the denominator, they cancel out. But then I have to put x plus 2 on this side and multiply it by 3, remember? Let's do it all in one step. So if I do that, I have on the top 3x plus 2 from here. X minus 1, I haven't touched him yet, and I have 7 here. I want to get rid of the x minus 1 on the bottom here. So if I put x minus 1 times by here, anything divided by himself is 1, so that cancels to 1. But I have to balance the other side by putting that here. So if I rewrite everything here, I should have 3 times x plus 2 is equal to 7x minus 1. Now expand as always. We want to expand. So I have 3x plus 6 equals 7x minus 7. Algebraic terms on one side, numbers on the other. So let's subtract 7x here to get rid of it on this side, but we have to subtract 7x on this side. And of course, we add the little plus sign between them. And then let's put this 6 over here. So if we want to put that 6 over there, we subtract 6, so it goes to 0, and then we subtract 6 here. And now we can rewrite it. So notice my equal sign is nice in line. So if you're doing these questions, try to keep your equal sign right in a nice straight line. Negative 7x and 3x is negative 4x. Negative 6 subtract, negative 7 subtract 6. So we subtract more and we end up with negative 13. Finally, we cancel out the coefficient in front of the x, but we have to do it from this side, and we have a negative divided by negative makes this a positive, and 13 over 4 I would just keep as a fraction, and there is our final answer. All right, you can keep this. We don't have to put a plus sign here if we don't want, because we know it's positive. So there you have two examples that are a little bit more difficult in the 6B part of the book here. Question number 3.